In this problem, we have to solve this absolute value inequality such that it has negative 3 times the absolute value, 6x plus 5, plus 9 less than negative 6. So the first thing we'll have to do is isolate the absolute value. So we'll have negative 3 times 6x plus 5, an absolute value, plus 9 less than negative 6. The first thing we'll do is we'll subtract 9 from each side, and we'll get negative 3 times 6x plus 5. The 9's cancel out on the left, and negative 6 minus 9 leaves me negative with negative 15. Now I can use the multiplication principle and go ahead and divide each side by this coefficient of negative 3. But right away, when we notice we're dividing or multiplying by a negative, we'll have to go ahead and reverse the inequality symbol. So this changes the less than to a greater than. And I have left on the left side absolute value 6x plus 5 greater than positive 5. Since this is a greater than absolute value inequality, then we have to split this into two different inequalities going in opposite directions. So first we'll have 6x plus 5 greater than 5, 6x plus 5 less than negative 5. Basically, it looks like one's going off to negative infinity and the other one's going off to positive infinity. All right, so let's go ahead and solve each one. So these are just linear inequalities that we're used to. And then we get x is greater than 0. Okay, or let's go ahead and subtract 5 here from each side, and we get 6x less than negative 10, and therefore x is less than negative 10/6. And we can reduce this to be x less than negative 5/3. So the solution is x greater than 0 or x less than negative 5/3. So what does this look like? Well, let's go back to the number line. These are strict inequalities, so it'll be a parenthesis going out towards negative infinity, x less than negative 5/3. The one that's greater than 0 going towards positive infinity would be 0. So rewriting this in interval notation, we have negative infinity up until negative 5/3 with a parenthesis because of the strict inequality. Union, jump over the gap, right, and go to 0 all the way out to positive infinity.